Today, we're going to see how to get started with MAX 31331 real-time clocks. Hello, I'm Suvendu. I'm an application engineer at Analog Devices. The MAX 31331 is an ultra-low power real-time clock that consumes only 65 nanoamperes of current and can power up to a wide range of voltage supply from 1.1 to 5.5 volts. It supports a wide range of crystals with any load spec and also has a power management unit that can switch to battery backup when the system power drops below 1.5 or 2 volt as it is programmed. So let's have a look at the MAX 31331 shield board. The MAX 31331 shield board can evaluate the WLP and the TDFN packages of the IC. The box contains the shield board, the 32625 Pico board, and a micro USB cable that can connect to your PC. Let's have a look at the jumper settings to enable the WLP path on the shield board. The JU4 has to be connected to 2 and 3 to connect the system supply to the 3.3 volts from the Pico. JU10 and JU11 has to be connected to enable the I2C communication. JU2 to be connected at 1 and 4 to make the super cap as the battery backup supply. Connect JU13 to connect the super cap to the VBAT pin of the IC. Connect JU7 to connect the VCC pin to the system supply. Let's have a look at the GUI. This is the MAX 31331 GUI. Make sure the auto update is clicked to read the time and date on the RTC. The GUI allows you to configure the date and time, to configure the alarms and timer of the RTC, to read the registers of the RTC, and also evaluate the timestamp feature of the RTC. Let's go ahead and input today's date and time on the RTC. I have populated the appropriate parameters for configuration of today's date and time. I go ahead and click set. And now you can see the parameters have changed and the seconds are incrementing. Now we will be evaluating the power management feature of the RTC. I'll make the relevant jumper settings and be right back. I'm back and we have two sets of power supply and pico ammeters. One set is for the VCC and other set is for the battery backup VBAT. We are connecting the VCC to TP5 as VCC external. We are changing the connections of JU4 from 2 to 3 to 1 to 2 and connecting the pico ammeter across JU7. Similarly, for VBAT, we are connecting the external power supply to TP2 and the pico ammeter at JU13. I have changed JU2 connection to 1 to 2. As you can see, the IC is powered up and consuming power from the VCC. The pico ammeter here reads the timekeeping current of 65 nanoamps. I would go ahead and turn off the supply and you would see that the IC would switch its power supply to VBAT and the pico ammeter connected on the VBAT pin would turn off with 65 nanoamps. There you go. Now the IC is powered up with the VBAT. When I turn on the VCC, the power would switch back to VCC. So all this while, you could see that the time was clicking on the GUI. So this demonstrates the power management feature of MAX 31331. For more information, visit maximintegrated.com. That's it for today. Thank you.